Hello again. In this video, I'm going to go over this homework problem from 310. So in this problem, we're supposed to find the derivative of y with respect to x, where y is equal to the natural log of the inverse tangent of 4x to the fifth. Okay, so let me show you how you can do this. Now, if we're going to find this derivative with respect to x, right, dy dx, we're going to have to use the chain rule to do this. And that's because this function over here is a composition of several functions. And anytime you take the derivative of a composition of functions, you need to use the chain rule to find the derivative. And so one form of the chain rule says that dy dx, the derivative of y with respect to x, is the same as the derivative of y with respect to u times the derivative of u with respect to x. Okay, now we're actually going to have to use the chain rule several times here. So we have to be very careful as we proceed through this. The first time we use the chain rule, we're going to think of this as our inner function. Okay, so I'm going to label this as u, the inverse tangent of 4x to the fifth. Okay, and that's sort of the inner function in this composition. And then the outer function will be the natural log. In fact, I'm going to write it y is equal to the natural log. And now, since we called this u, I'm going to label it as u, right? It'll be the natural log of u. And that's our outer function. Okay, so if you form a composition with these two functions, you'll end up with this function here. Okay? And now I'm going to find the derivative of y with respect to x. Okay? So let me find this piece first. So to find the derivative of y with respect to x, we're actually going to find the derivative of y with respect to u and then multiply it by the derivative of u with respect to x. So let's find this dy du first. Okay, well, the derivative of y with respect to u would be the derivative of this function here, right, with respect to u. And of course, that's just 1 over u. Okay, and then if I substitute u back in, remember u is equal to this inverse tangent of 4x to the fifth, then I'll just get 1 over inverse tangent of 4x to the fifth. Okay, and so that's my outer derivative. Dy du. Okay, and now I'm going to multiply that by the inner derivative, which is the derivative of u with respect to x. Okay, so du dx is really the derivative of this inverse tangent of 4x to the fifth with respect to x. But notice that if I'm going to find the derivative of this function here with respect to x, that I'm going to have to use the chain rule again because this is a composition of functions unto itself. So in order to find this derivative, du dx, I'm going to have to use the chain rule again. Okay, so I'm going to do that on the side, and when we're done, I'll come back and put that derivative into here, and once we know what this derivative is, we'll multiply it by dy du, and we'll have the derivative of y with respect to x. Okay? But I'm going to do this on the side. So I'm going to go find du dx on the side. Okay, so here's our u, right? It's inverse tangent of 4x to the fifth. Okay, and we want to find du dx, the derivative of u with respect to x. But to do this, we're going to use the chain rule. So what we're going to do is we're actually going to find, well, let's label this. Let's label this one. So we have this is our inner function now. I'm going to label that as v. So let's call 4x to the fifth v. Okay, that's kind of our inner function here. Okay, then u would be inverse tangent of v. right? Because I'm calling this v in here. Okay, and then if I want the derivative of u with respect to x, then I can just use the chain rule to do this, right? I can say that's equal to the derivative of u with respect to v times the derivative of v with respect to x. If I multiply those two derivatives together, I'll get the derivative of u with respect to x. Okay, so let's find du dv. Okay, well, that's the derivative of inverse tangent of v with respect to v. Okay, and if you remember, the derivative of inverse tangent of v would be 1 over 1 plus v squared. And I'm going to go ahead and substitute for the v. We know v is equal to 4x to the fifth. Okay, so it's the same as 1 over 1 plus v squared, but v is 4x to the fifth, right? So it's 1 plus 4x to the fifth squared. And I'm going to go ahead and simplify that. When you square this out, you can square each of these individually. So 4 squared is 16. And then x to the fifth squared, that's the same as x to the fifth times x to the fifth. And so you would add exponents there, you get x to the 10th. Or you could just say x to the fifth squared, you multiply exponents there. So you got two options there. You know, you could multiply exponents, right? That gives you x to the 10th. Or you can think of this as being x to the fifth times x to the fifth. That's what it means to square x to the fifth. And then you just add exponents here and you get x to the 10th. Or you just count up how many x's you have, right? And there's a total of 10 of them. And so it's x to the 10th. Okay? Okay, so that's du dv. Okay? Which is this outer derivative here. And then I'm going to multiply that by the inner derivative, which is dv dx. Okay, now dv dx would be the derivative of this function with respect to x. And we can just use the power rule to find that. Of course, 4 is a constant, so it sits out front. And then you just take the derivative of x to the fifth, which is 5x to the fourth, and then times the constant 4. All right, so that's 20x to the fourth. Okay, and so then, again, going back up here, that's the inner derivative, and this is the outer derivative. When I multiply them together, I get the derivative of u with respect to x. Okay, and so that is our du dx up here, which is the inner derivative for the first time we use the chain rule. Okay, so I'm just going to write that as 20x to the fourth over 1 plus 16x to the 10th. Okay, and then if I multiply the outer derivative here times the inner derivative here, then I'll get dy dx, right? So I'm just going to substitute that in. So dy du, the outer derivative here, is this. Times its inner derivative, which is this. Okay, x to the 10th. Okay. Okay, so that's the final answer. And just let's clean it up a little bit, but that's pretty much it. Here was our original function, and we wanted the derivative of of y with respect to x. And of course, using the chain rule, it's this. So that's the same as 20x to the fourth on top divided by inverse tangent of 4x to the fifth all times 1 plus 16x to the 10th. Okay, so that's our final answer. Okay, let's check it and see. I'm going to go back to my math lab and see if that's the correct answer. So yes, you can see that's correct, right? 20x to the fourth over inverse tangent of 4x to the fifth, and that's multiplied by 1 plus 16x to the 10th. Okay, so I hope you found this video helpful. Again, I'll continue to work some of the homework problems from chapter 3, and hopefully you'll get a chance to look at some of the other videos I've got for those as well. Okay, bye-bye.